आज का जो हमारा टॉपिक है वो इलेक्ट्रिक फील्ड एज अ ग्रेडियंट ऑफ इलेक्ट्रिक पोटेंशियल। इस टॉपिक पर आज हम लोग बात करने वाले हैं और हम कंक्लूजन निकालेंगे कि हमारे पास इलेक्ट्रिक फील्ड और पोटेंशियल के बीच में क्या रिलेशन होता है। सपोज करें कि ये हमारे पास एक्स एक्सिस है और एक्स एक्सिस पर कोई पॉइंट O है जिस पे प्लस क्यू चार्ज रखा है। इसी एक्सिस पर हमने दो पॉइंट्स ले लिए ए और बी। डिस्टेंस जो पॉइंट ओ से ए तक का है वो हमारा डिस्टेंस आर है और ए बी जो है वो एक छोटा डिस्टेंस जिसको हम स्मॉल डी आर से डिनोट कर रहे हैं। प्लस क्यू चार्ज की वजह से हमारी जो इलेक्ट्रिक फील्ड है वो इस डायरेक्शन में है in all possible direction along x-axis. E is the electric field that is moving in this direction. अब सपोज करें कि हमारे पास कोई टेस्ट चार्ज Q नॉट है। Q नॉट को हमें पॉइंट B से पॉइंट A पर लेकर आना। Q नॉट टेस्ट चार्ज को हम B से A पॉइंट पर लेकर आ रहे हैं। ये जो Q नॉट है ये हमारी इलेक्ट्रिक फील्ड की ऑपोजिट डायरेक्शन में मूव करेगा और जब भी चार्ज मूव करेगा तो कुछ ना कुछ वर्क डन होगा। उस वर्क डन को अभी हम फाइंड आउट कर रहे हैं। लेट प्लस क्यू is a charge at point O that is along x-axis as shown in the figure. A and B are two points lying within the electric field E of plus Q charge. Let Q naught is a test charge to be moved from point B to A. The distance between B and A is dr as shown in the figure. Now let F is the force experienced by test charge Q naught due to charge प्लस Q। जो हमारे पास Q नॉट टेस्ट चार्ज है वो फोर्स F एक्सपीरियंस कर रहा है बिकॉज ऑफ द चार्ज Q। Because between these two charges there will be lying the force, and this force is given by the relation F is equal to Q naught E. Force is equal to the product of the charge and the electric field. Mark it as equation number 1. Also, the work done in taking charge Q naught from B to A is, now we see that there is a small distance dr to be shifted, so work done also is to be taken small, and dw is the small work done that we are taking for the Q naught charge to move from B to A, and this is being given by force into distance. This is the dot product of the force and the distance to be moved. Now if you'll see, the force and the electric field are moving in this direction, whereas the dr to be moved from B to A, this is in the opposite direction. So the angle between two of them is 180 degree, or we can also write it down F minus dr because of the opposite direction. So this F into dr is the small work done, and we'll put the value of F from equation number 1 to equation number 2 using the value of F from equation 1 to equation 2. We have the work done is equal to Q naught E minus D, or electric field is equal to work done upon the test charge minus T. Now, according to the definition, the work done per unit charge is given by the potential, and since small work done is there, so we'll denote with dV, small potential. So the value dV by dr, this is the potential that is changing with respect to the distance, and this is known as the potential gradient. So electric field is equal to minus sign with the potential gradient. That is what we have concluded. So this is what we have concluded. The electric field is the negative of the potential with respect to the change in the distance. This quantity dV by dr is rate of change of potential, and rate of change of potential with respect to the distance. This can be added with respect to the distance, and is known as the potential gradient. So if we sum up, we find out the electric field intensity at a point in an electric field in a given direction is equal to the negative potential gradient in that direction. What is the physical significance of this minus sign? Here, the negative sign signifies this thing, that electric potential decreases in the direction of electric field. So this is an important conclusion that we have drawn along with the relation of the electric field and the potential.